Hello everyone. Welcome to Brain Blitz Audios. In this episode of Cbse board exam, we'll be dealing with previous year questions of mathematics asked in Cbse board exams. We'll be dealing with the 5th chapter of grade 12, that is continuity and differentiability. Let's look at our first question. If x raised to y is equal to e raised to x minus y, then prove that dy by dx is equal to log x divided by 1 plus log x the whole square, or log x divided by log xe the whole square. Now let's look at how to solve this question. So over here, the given equation is x raised to y is equal to e raised to x minus y. So in order to take differentiation, what we first do is we take log on both sides. So then we'll get log x raised to y is equal to log e raised to x minus y. If log a raised to b is present, we can write it as b into log a. So now using this property, we can write the left-hand side as y log x and the right-hand side as x minus y into log e. Now note that the base of this logarithm is also e. So log e to the base e is equal to 1. So the right-hand side will be x minus y. Log e is equal to 1. Base is e. So now we have y log x is equal to x minus y. So now what do we do? So what we do is we take y log x plus y is equal to x. We took that y to the left-hand side. And now we take y common, so y into 1 plus log x is equal to x. And therefore we'll get y is equal to x divided by 1 plus log x. So over here, we do differentiation. On differentiating with respect to x, we will get on the left side dy by dx. And on the right-hand side, we'll apply the quotient rule. So therefore, the numerator becomes 1 plus log x into d by dx of x, which is 1, minus x times d by dx of 1 plus log x. So d by dx of 1 is 0 minus d by dx of log x will be 1 by x. And we divide that by 1 plus log x the whole square. So now we'll get 1 plus log x and then minus, since there's an x on the numerator and the denominator, they get cancelled. So we have a minus 1 divided by 1 plus log x the whole square. So therefore dy by dx is equal to log x divided by 1 plus log x the whole square. And if you notice, that is what we're asked to prove. So we got that. So that is equal to the RHS. But the question also asks us to find dy by dx as log x divided by log ex the whole square. How do you convert this? So dy by dx is equal to log x divided by 1 plus log x the whole square. Now, we know that log e is equal to 1. Now we apply that property. So we get log x divided by log e plus log x, the whole squared. And since log a plus log b is equal to log ab, we will get dy by dx as log x divided by log xe, the whole squared. And that is also equal to the RHS. So therefore, we've solved the first question. Now, our next question. Differentiate tan inverse of 1 plus x squared, the whole root, minus 1 divided by x with respect to x. So this is a pretty straightforward question. So we will consider y as tan inverse of 1 plus x squared, the whole root, minus 1, the whole divided by x. And we keep that in a bracket. But how do we simplify further? For that, we take x equal to tan theta. Now, when we take x is equal to tan theta, we should know that theta will be equal to tan inverse x. This will be useful at a later stage. So now we'll put x as tan theta. So we get tan inverse of 1 plus tan square theta, the whole square, minus 1 divided by tan theta, which will become tan inverse of 1 plus tan square theta, the whole root, will be equal to sec theta. So now we put the value sec theta minus 1 divided by tan theta. Now to proceed further, you should know that sec theta is equal to 1 by cos theta, which we studied in grade 11. And tan theta is equal to sine theta by cos theta. Again, what we learned in earlier classes. So now y is equal to tan inverse of 1 by cos theta minus 1 all divided by sine theta by cos theta. So now what we'll get is tan inverse of 1 minus cos theta divided by sine theta. Now, how do we reach here? Now, since this is 1, we multiplied it by cos theta. So we'll get 1 minus cos theta by cos theta divided by sine theta by cos theta. The cos theta was common, so we canceled it to get tan inverse of 1 minus cos theta divided by sine theta. Now, for further simplification, what we do is we take 1 minus cos theta as 2 sine square theta by 2. And sine theta will be equal to 2 sine theta by 2 times cos theta by 2. So therefore, y is equal to tan inverse of, and in the bracket, 2 sine square theta by 2 all divided by 2 sine theta by 2 cos theta by 2. So here we can cancel it. 2 and 2 gets cancelled. 1 of the sine theta by 2 gets cancelled. So we'll get tan inverse of sine theta by 2 divided by cos theta by 2, which is equal to tan inverse of tan theta by 2. So therefore, y will be equal to theta by 2. But now we put the value of theta, that's tan inverse x, so we'll write tan inverse x divided by 2. So y is equal to tan inverse x by 2. From here onwards, it's just differentiation. So dy by dx will be equal to d by dx of 1 by 2 times tan inverse x. And the differentiation of tan inverse x is 1 by 1 plus x squared. So we'll get 1 by 2 into 1 plus x squared as our final answer. So that's the second question done. Now we'll move on to the final question. Find the value of a if the function fx defined by fx, which is 2x minus 1 at x less than 2, a at x equal to 2, and x plus 1 at x greater than 2, is continuous at x equal to 2. So this equation is continuous at x equal to 2. Now that means the left-hand limit, LHL, is equal to the right-hand limit, RHL, which is equal to the function at the point of continuity. So fx at 2 will be equal to LHL and RHL of this function. Now, the value of the LHL will be limit x tends to 2 minus, because it's continuous at 2, into f of x, which is equal to limit x tends to 2 plus f of x, which is equal to f of 2, the function at x equal to 2. So the left-hand limit and right-hand limit are stuff that we learned in grade 11. So we're applying them here. Now let's find each of the limits. So limit x tends to 2 minus f of x is written as limit x tends to 2 minus, and 2 minus means it's less than 2. So when x is less than 2, fx is 2x minus 1. So limit x tends to 2 minus 2x minus 1. So when we apply the limit, we'll get 2 into 2 minus 1. That's 4 minus 1 equals 3. Now let's put the right-hand limit. Limit x tends to 2 plus f of x. Now that will be equal to limit x tends to 2 plus, and so here x is greater than 2. So at that point, f of x will be x plus 1. So limit x tends to 2 plus x plus 1. So we'll put the limit in, so that's 2 plus 1 equals 3. So the left-hand limit is equal to the right-hand limit. Next, we'll find out f of 2. So that is fx at 2. So fx at x equals 2 is given as a. Now, since the function is continuous, f of x, f of 2 will be equal to LHL, which is equal to the RHL. So that gives us a equals 3. And the question was to find the value of a. So the value of a is 3. So that concludes our final question and this tutorial on continuity and differentiability. We hope that you enjoyed this video. For more useful and interesting content, please subscribe to our channel, Brain Blitz Audios. We'll be back with more learner words, stories, mind maps, NEET preparation, and of course, more question paper solving of Cbse board exams. Until then, take care, stay safe. Ta-ta for now.